everyone, welcome to the Byju's Exam Prep, the most comprehensive app for all exams. Now, we are going to discuss operational amplifier from analog circuit. Okay guys, and this is a very important topic for GATE 2023. First of all, let me know that sound quality, picture quality, everything is fine. And yes, please inform me that sound quality, picture quality, everything is fine. Okay, I think everything is fine now. Okay, now it is a GATE champion series and we are going to discuss around 500 questions. Okay, and it is just like what live workbook. So join, subscribe our channel, like the session and share the link of this session. Okay, and from different subjects we are going to discuss around 500 questions so that it is a quick revision for all subjects and you will get variety of questions, NAT type, MCQ, that is multiple choice question, and what MSQ, multiple select question. Okay, on different topics. So it is the operational amplifier and myself Sanjay Rathi. First of all, what I am going to discuss, I will explain you. In this session, we will discuss application of the operational amplifier, right? So you have to solve the question on inverting operational amplifier. That is the basic thing. MSQ we will solve. Second, non-inverting we will solve question, direct question. Third, we will solve questions on what differential amplifier, variety of questions on differential amplifier and instrumentation amplifier. Instrumentation amplifier is important for instrumentation branch. Okay, and we can get question in electronics and electrical branch also. Jaya, Prachi, very good afternoon. And now then we will get the voltage follower and we will solve questions on what filters. Filter means low pass filter, high pass filter, band pass filter and what band reject filter, all pass filter, so that you will get the idea about the filters. And then voltage to current converter, and current to voltage converter, and oscillators by using operational amplifier. But you are not going to get the questions in this sequence. Okay, and I will mix the question, 1 marks question and 2 marks question randomly. Numerical answer type, it may be MSQ or what MCQ. So ready guys, ready to take challenge? Everyone, please give me the answer in the comments box. And remember, if you want to cover all this topic, it is the session for you. It is a quick revision and you will get the idea which type of questions we may expect in GATE 2023. And tomorrow we are going to discuss what? Waveform generator. Waveform generator means bistable multivibrator, monostable multivibrator, astable multivibrator, 555 timer. Questions on these topics. Tomorrow 4 p.m. on the same time, right? So first of all, my introduction, myself Sanjay Rathi. I'm having around 21 plus years of teaching experience, and on the basis of this analog, this is very important subject, I have qualified and selected for engineering services exam multiple times. These are my ranks: AIR 16 in ESE 2005, AIR 21 in ESE 2008, and I have mentored more than 1 lakh students for these competitive exams. These are my area: network, digital, control, EDC, analog and advanced electronics. Then it is an important information for you. You have only 5 months to go. It's GATE 2023 with the free GATE Achiever series. To join this, register here for this. Okay, yes, we have only 5 months, right? September, October, November, December and what? January. In month of Feb, we have to give the GATE 2023. First question on your screen, right? It is of 2 marks question. Simply give me the answer. What is the answer? Now randomly in technical you are going to get what? Random question. It may be of 1 marks, it may be of what? 2 marks. Random questions. The first question is of 2 marks. Everyone, what is the answer for this question? Tell me. In the given current to voltage converter circuit, a current source has an output impedance of Rs 100 kilo and an output voltage of V0 minus 10 volt. This is the minus 10 volt. When the signal current is Is 100 microampere, this current is 100 microampere. What will be the value of Rf? What should be the value of Rf? It is a MCQ multiple choice question. One correct answer, negative marking with. Okay. Give me the answer. What is the answer for this particular question? Ask your friend to join the session. Right. Now, very simple question. Ready. Okay. बताइए जरा. It is a what is the name of this circuit? So here we are giving the current. Here it is the internal resistance of the current source. This current is converted into what voltage? This current is converted into voltage. Right. Now, how we can convert? This voltage is given as minus 10 volt. According to virtual short concept, this voltage and this voltage is 0. For ideal operational amplifier, virtual ground process, Vp positive terminal voltage is equal to negative terminal voltage, that is 0. Now, what is the current source? This is the current source Is. This voltage is 0, this voltage is 0. And therefore, what will be the current through the Rs? The current through Rs will be 0. Once the current through the Rs 0, this Is, because that terminal voltage is 0, this is a 0, 0, 0. What is the current? 0. Now this Is will move here. Now second thing, what is the current enter into the operational amplifier? 0. Why? Because the input resistance of the ideal operational amplifier is infinite. So what is the current enter into the terminal of the operational amplifier? 0. And that's why this same current will become I2. I2 is nothing but Is. Same current will pass through the RF. Now the voltage at this point is 0. Voltage at this point is V0. So we can write what is the value of this voltage. What is the drop across the RF? The drop across the RF is given by Is into RF. That is nothing but 0 minus V0. And this is 0 minus of minus 10, because it is 10 volt is given, upon Is. It will give you the value of RF. So what is the value of the Is? 100 microampere. And what is the output value? 10 divided by 100 microampere. This is cancel. It will become 0.1 into 10 to the power minus 6. Solve this. It will become 100 into 10 raised to power plus 6. This will become 3. This is nothing but 100 kilo ohm. So what is the answer for this question? 100 kilo ohm. So this is the answer. And the name of this circuit is current to voltage converter. Current to voltage converter. Now first topic is over, current to voltage converter. Okay. So any doubt? If you have any doubt, then you can ask. This is a standard circuit. We have to use what? Virtual short concept simply, and that current enter into the operational amplifier is 0. Now second question on your screen. Okay. Feedback mechanism is a voltage. What is the note this question. The inverting operational amplifier shown in the figure has an open loop gain of 100. Feedback mechanism is, what is the feedback mechanism? There are 4 statements and it is MSQ. This question is visible to you, everyone? Yes. 1 kilo ohm, 10 kilo ohm, V in, V out. Basically, it is a inverting operational amplifier. Open loop gain given as 100 means it is not an ideal operational amplifier. And we have the MSQ, multiple select question, multiple correct options. So which answers are correct? It is a 2 marks question. 2 mark question in GATE exam. Yes, everyone. Which answers are correct? Read question carefully and give me the answer. Yes. The inverting op amp shown in the figure has an open loop gain of 100. Feedback mechanism. Yes, please. Now, inverting op amp is, in a inverting operational amplifier, always remember the feedback mechanism is what? Voltage shunt feedback. So what is written here? Voltage series feedback. That's why the first statement is wrong. Remember that. In a non-inverting, the feedback mechanism is voltage series feedback, and in inverting operational amplifier, the feedback mechanism is what? Voltage shunt feedback. That's why the first is wrong. Second, what is the V0 by Vs? It is given -9. But as you know, under ideal condition, -10 by 1. That is -10 by 1. The voltage gain should be -10. But under ideal condition, AOL is given, means it is not ideal condition, it is practical condition. So how we can solve this? If it is given practical condition, always remember what is the voltage gain. V0 by Vin is called internal gain into beta upon 1 plus AV beta into RF by R1. That is the gain. RF by R1. What is the AV beta? -100. What is the AOL given in the question? 100 upon beta. Beta here, RF by R1 plus RF. 10 divided by 10 plus 1. That is 10 by 11. That is the value of the beta. Put here. Upon into RF. 10 by 1. Everyone please calculate this value. 11 cancel. This will become -1000 divided by 1011, I think. This is the 10 by 1. So definitely it is less than what? Definitely it is less than 10. Magnitude will be less than 10. So what is the answer here? And check my calculation also. So it will become nine point something. Okay. So that is the value. This is the RF by R1 plus R. Oh, this is not the beta. This is not beta. Remember. No one is giving me comments. What is the problem, guys? Everyone, in a previous session already I have discussed the non-inverting operational amplifier or inverting operational amplifier. So what is the value of the beta? Remember, beta is equal to R1 upon R1 plus RF. This is the drop across that R1 upon R1 plus RF. 1 upon 1 plus 10, that is become 1 by 11 actually. If it is 1 by 11, so what is the AVS? AVS will become minus 100 into beta 1 by 11 upon 1 plus 100 by 11 into RF by R1. What is the RF? 10 by 1. Now 11 cancel, minus 1000 divided by 111. Right? And that is, you will get the answer nearly equal to minus 9. Nearly equal to what? Minus 9. So that is the value. I think this formula, in a practical condition, always remember the formula. This is about the inverting op amp. Inverting operational amplifier. And always remember the magnitude of AVS in practical condition is always less than what? RF by R1. RF by R1. Now, this answer is correct. This answer is wrong. Input resistance seen by VS is 1.1 kilo ohm. Input resistance. What is the input resistance seen, everyone? According to the Miller's theorem, what is the input resistance seen? It is simply, everyone in comments box, give me the answer. What is the input resistance seen in case of non-inverting operational amplifier? PDF will be available to you after the class. Please join my Telegram channel, that is Electronics by Sanjay Rathi. Okay. RF, R1, inverting operational amplifier. What is the input resistance? Practically, you have to apply the Miller's theorem. And then after applying the Miller's theorem, this is 10 kilo ohm, this is 1 kilo ohm, and this is the Vin. This resistor will become 1 minus AV. 1 minus AV. 10 upon 1 minus AV. Right? And it's up to this point, if nothing is given, then always remember up to this point the input resistance is what? Infinite. Now we are talking about the input resistance, means what is the input resistance seen by the Vin? What is the input resistance seen by the Vin? Rin, that is given by 1 kilo ohm. This is plus 10 divided by 1 minus AV. Now in this case, we are taking VI. What is the VI? Before applying the Miller's theorem, what is the VI? When we are taking VI is equal to negative terminal minus positive terminal, always you have to take the AV negative. Actually, AOL is given in the question 100, no problem. But when it is given 100, means we are taking the AV is equal to VP minus VN. But when we are changing VI is equal to VN minus VP, always take AV is equal to what? Minus 100. And to applying the Miller's theorem, we are taking it what? Vn minus Vp. So remember that thing. What will be the formula? 1 plus 10 divided by 1 minus of minus 100. So almost it is 100, 1 is negligible. It will become 0.1. So what is the resistor? 1.1 kilo ohm. That is the right answer for this question. Okay. So normally students are saying that, sir, answer is simply R1. What is the input resistance? R1. But it is under ideal condition. It is a practical question. So R1 greater than R1. So this answer is also correct. And finally, the error in the approximated calculation will be. Error in the approximated calculation, very simple. 1 minute. Error in the approximation is percentage error 1 upon AV beta into 100%. Remember the error. What is the AV? 100. Beta 1 by 11 already we have calculated into 100%. 100 cancel. What is the error? 11%. So what about the next, this answer? This is also correct. So answer for this question is B, C and what? D. B, C and D. Now some student will ask that, sir, we have to calculate all this value. Yes, it is a standard circuit. It is a standard circuit, means inverting operational amplifier, ideal condition and practical condition. It is a standard answer. This we have the standard formula for this and we have the standard formula for this. You have to use this formula and get the answer. Okay, so first question on current to voltage converter. Second question on what? Inverting operational amplifier. Everyone tell me what will be the next question. Any guessing? On which topic you want? Application of the operational amplifier. Application of the operational amplifier. Now next question on voltage to current converter. It is the MCQ. It is a voltage to current converter with grounded load. But in a GATE exam, they will not mention the name. Voltage to current converter with grounded load. Why it is called grounded load? Because this is the load and the other terminal is connected toward the ground. Now, tell me what is the answer? 1 mark question only. 1 mark question. Okay, in 2023, they will ask random questions. 1 mark question, 2 marks question, numerical answer type, MCQ, okay, or what, MSQ. So, they will not follow the sequence. कोई sequence नहीं होगा. They will give you the random questions. Right? It is a 1 mark question, MCQ question. Everyone try to give me the answer. Very, very easy. Standard. Okay. Everyone please like the session. Okay. And tomorrow I am going to take one very important one, waveform generator. Quick revision of waveform generator, bistable multivibrator, or stable multivibrator, and what? Monostable multivibrator with relaxation oscillator. If you want, then please subscribe our channel and like the session. Now, what is the load current IL in the circuit below? What is the load current? 1 kilo. In this question, first of all, we have to check the condition. What is the condition here? This is RF, this is R1, this is called RP. You can give any name, and this is called R2. And actually, this is the RL. It is a voltage to current converter. Now, we have to check the balance bridge condition. We are saying that simply RF by R1 is equal to RP by R2. First of all, check this. Now, so RF by R1, 1 by 1, RP by R2, 1 by 1. This is correct. It is satisfied. Once this condition is satisfied, always remember, then check where the input is connected. Connected to inverting terminal or non-inverting terminal. Here the input is connected to inverting terminal. This is the inverting minus. If it is connected to inverting, then we can say IL is equal to minus input divided by R2. This is the R2. If it has the value 1 kilo ohm, this. If the input is connected to non-inverting terminal, the answer will remain same, but it will be of positive sign. So what is this? 10 divided by 1. 10 divided by 1, and answer is minus 10 milliampere. Okay, 1 mark question, standard circuit. So what is the answer? Minus 10 milliampere, the B for Bombay. And this is called voltage to current converter. Okay, Karan Gupta and Hanuman Kumari. Okay. Hema, Jaya, Now, this is the standard question. Next one. Next two. Which of the following statement is wrong about the voltage follower? MCQ with negative marking, 1 mark question. Okay. Give me the answer. Which answer is correct? I am waiting for your answer. Which answer is correct? Which of the following statement is wrong about the voltage follower? It is used in designing of sample and hold circuit. Feedback factor beta is nearly equal to 1. Feedback mechanism is voltage series feedback. Closed loop gain is exactly equal to what? 1. Voltage follower. Right. Which answer is correct? Okay. If it is a voltage follower, remember, this is a voltage follower, non-inverting operational amplifier with, this is the circuit. This is a voltage follower. It is a non-inverting operational amplifier. And in non-inverting operational amplifier, the feedback mechanism is voltage series feedback. And that's why this is correct. We have to choose the wrong answer. So this is correct. And the feedback factor beta is nearly equal to 1. Yes, beta is R1 upon R1 plus RF. R1 upon R1 plus RF. Right? So it is nearly equal to 1 for voltage follower practically. Watch this diagram. It is a standard circuit. What is the R1? 0. What is the RF? Sorry, what is the R1? If it is open circuit, ideally the R1 is infinite. And it is a short circuit. So what is the value of the RF? 0. So when I am dividing, it will become what? 1. Nearly equal to what? 1. Practically it is nearly equal to 1. It is used in designing of sample and hold circuit. Definitely that is the application of the voltage follower. This is the sample and hold circuit. We are having negative feedback, and here we are using a switch, and here we are connecting one capacitor. This circuit is called sample and hold circuit. Here we are giving the input, here we are applying the control voltage. Means we are applying the pulse here. Okay, and this is a P channel MOSFET. Normally we are using the P channel MOSFET. So when we are giving the negative voltage, switch will be on, it will sample the VI, and when we are giving the 0 voltage, switch is off, output will be 0. This is called sample and hold circuit. Right? So this is also correct. It is used in designing of sample and hold circuit. Feedback factor beta is nearly equal to 1. Feedback mechanism is voltage series feedback. Now what is written here? Closed loop gain is exactly equal to 1. No, it is not exactly equal to 1. It is nearly equal to 1. Right? And that's why it is called voltage follower. Output voltage will follow the input voltage. And that's why this answer is wrong. If it is written here closed loop gain is nearly equal to 1, then we can say it is not exactly equal to 1. We are talking about the practical voltage follower. It is not written ideal condition, where if nothing is written, you have to consider what? Practical condition. The answer for this question is D. We have to choose the wrong answer. This is right, this is right, this is MCQ. And that is the sample and hold circuit. Now, second question on involved voltage follower. Yes, that is a numerical based question. Again, it is a 1 mark question, MCQ. Multiple choice question, MCQ, 1 mark, only 1 mark question. You have to give a simple Simple calculation. Already I have given you the hint that the gain bandwidth product for any amplifier, that is the unity gain bandwidth product for any amplifier, is what? Constant. First of all, find the gain of the amplifier. What is the gain of the amplifier for this voltage follower? The gain is what? Nearly equal to 1. That's why it is called voltage follower. And what is the gain bandwidth product? This is also represented as GBW. It is given as 12 kilohertz. So what is the bandwidth is equal to? Bandwidth is equal to gain bandwidth product divided by gain. 12 divided by 1. What is the bandwidth? 12 kilohertz. Highest bandwidth is available in case of what? Voltage follower. Why? Because it has lowest gain. Is there any lag? Why you are not able to give the answer in the comments box, everyone? Please try to give me the answer in the comments box, because it is just a live mock test. Okay, workbook. Just if it is solved by you directly, you can post your answer. Answer is A or B or C or D, and we have to solve within 30 seconds. Why? Because it is a direct question. What is the gain bandwidth product? Right? Okay, and in this way we can solve this type of questions. Okay, then next one, I think always remember, in case of voltage follower, we are going to get the highest bandwidth. Why highest? Because the gain is the lowest one. Gain is the lowest one. 10. 1 minute. And that is important information for you. The gate preparation free ebook. Download now. Link is in the description box. Okay. So go through the description box now, right, or just after the session, and you can download it. Gate preparation free ebooks are available on our channel. That is a very, very important facility available to you, right? It is free of cost, and definitely it will help you. Okay, so that is important information. Now again, focus on the question. Figure shows the non-inverting operational amplifier with AOL. How many zeros are here? 1, 2, 3, 4, 5 zeros. Yes. Figure shows a non-inverting op-amp. It is a MSQ, means again it is of 2 marks question. There is no negative marking. But if we are giving the partial answer, then you are not going to get any marks, 0 marks. But there will be no negative marking, and that's why we have to attempt what? MSQ. Suppose we are getting the A option or B option or C option, then definitely you have to attempt these questions. Okay. So give me the answer. What is the answer for this question? Figure shows the non-inverting op-amp with AOL 10 to the power 5, feedback factor, exact closed loop voltage gain. Now always watch the answer carefully. We are having the 2 answer for exact closed loop voltage gain, B and what? D. So out of B or D, only one will be correct. If it is the MSQ, go through the options also. If there are 2 options, exact closed loop voltage gain is 38.852, exact closed loop voltage gain is 39.984, we are having the 2 different answers. Then which answer is correct? Okay, so out of these 2, only one correct. Now we have to check the what is the feedback factor, what is the ideal closed loop voltage gain, right? Give me the answer, which answers are correct? Take your time. This resistor is given as 100 ohm, right? 100 ohm. Convert it into kilo ohm. This is the 3.9 kilo ohm. This is the RF. This is the R1. Some students are not comfortable with this. So please change the orientation, right? When we are changing the orientation, you will get the standard circuit for non-inverting operational amplifier, okay? And it will help you to find the gain, beta, and each and everything, right? Okay. So everyone, go through the description box. We have the number of links, and that is for you, for the students, okay? And definitely it will help you if you want any details, if you want any notes, ebooks, okay? And that is available in our description box. And you can join my Telegram channel if you want the PDF of this session. How many students want the PDF of this session? Everyone, give me the comments in the comments box. I am sharing my link of Telegram channel. Okay. To join this Telegram channel, that is Electronics by Sanjay Rathi. Now, the figure shows the non-inverting op-amp with AOL 10 raised to power 5, feedback factor, exact closed loop voltage gain, ideal closed loop voltage gain, exact closed loop voltage gain. Okay guys, how to solve this question? For non-inverting operational amplifier, one by one I will explain this. First of all, what is the feedback factor? Means the feedback factor is always R1 upon R1 plus RF. Draw the diagram. This is R1, this is RF. That is connected. There is a negative feedback, or in a positive terminal, input is connected, very small input, 50 millivolt peak to peak value. Okay, 50 millivolt peak to peak value, small input is connected here. Highest voltage is 15 volt, lowest voltage is minus 15 volt. This is 3.9 K and it is 0.1 K. What is the feedback factor? R1 upon R1 plus RF. Remember that. What is the R1? 0.1 divided by 0.1 plus 3.9. It will become 0.1 divided by 4. 0.1 divided by 4 is nothing but 0.025. Check my calculation. If it is 0.025, then the first answer is correct. What is the beta? Feedback factor is 0.025. Second, what is the ideal closed loop voltage gain? As you know, ideal closed loop gain for non-inverting operational amplifier is very easy. 1 plus RF by R1. If suppose the ideal operational amplifier, the gain become infinite, it is a standard answer. What is the 1 plus 3.9 divided by 0.1? So it will become 39 plus 1, 40. This is also correct. This is also correct. Now what is the exact voltage gain? We have to find the exact voltage gain. How to find the exact voltage gain? Already we have calculated the ideal voltage gain. Exact means practical condition. So in a practical condition, the exact voltage gain, everyone remember the formula. AV upon 1 plus beta AV. AV. What is the AV? 10 to the power 5 given in the question upon 1 plus. What is the beta? 0.025. into AV 10 to the power 5 given in the question. Some student will ask where it is given. So first of all, read the question carefully and note the data on your answer sheet. Then on your rough sheet, 10 to the power 5, read the 0, 1, 2, 3, 4, 5, that is the 10 to the power 5. Right, be careful, otherwise we can make silly mistake. Now, this is the answer. What is the exact answer for this question? Okay. 39.98. 39.98 means nearly equal to what? 40. Nearly equal to what? 40. Okay. Now, I am giving you the hint. If suppose the gain is very high, this is nearly equal to what? 10 to the power 6, or normally we are having the gain 10 to the power 6, or it is nearly equal to what? Infinite. It is the very high gain. If the very high gain, find the closed loop voltage gain, that is what? 40, and it will be nearly equal to that, but slightly less than that. Always remember, that will be slightly less than that. So 40 is the ideal condition, 39.984 is the practical condition, and 39.984 is nearly equal to what? 40. Okay, but always it will be slightly less than this value. If suppose we are using the gain 100, only 100, then answer will be what? B. It will be less. So that exact formula for the gain, remember that formula, AV upon 1 plus beta AV. So non-inverting is discussed, inverting operational amplifier is discussed. Already we have solved the question. Now next one, next question, voltage follower is discussed. Now the time to discuss what? Ideal operational amplifier and differential amplifier. Everyone give me the answer for this. Differential amplifier. Question on differential amplifier. What will be the answer? Differential amplifier has input 1050 microvolt and 950 microvolt with CMRR. What is the full form of CMRR? Give me the answer in the comments box. What is the CMRR? CMRR, right? A differential amplifier has input V1 1050 microvolt and V2 950 microvolt with CMRR 1000. What is the error in the differential output? 10%, 1%, 0.1%, 0.01%. That is the MCQ. And again it is of 1 marks question. Previous question of 2 marks. Okay. Yes, Ravi Shankar. This is a common mode rejection ratio. How to solve this question? Solve it on your rough page. For any differential amplifier, we are having the 2 output. One is called ADVD and another is called ACVC. AD is what? Differential gain, and VD is the difference signal. And what is the AC? AC is called common mode gain. And what is the VC? It is called common mode signal. Here the VC and AD ADVD plus ACVC. VD is the difference of the 2 signal, V1 minus V2. And VC is what? Average value. This is called common value. V1 plus V2 by 2. This is the common of the 2 value. V1 plus V2 by 2. This is called mid value or common value or average value. And this is the common gain, AC. It is unwanted. And it is what? Wanted. Okay. If this is wanted, then how we can calculate? Wanted or unwanted? We have the value. So what is the error? Actually, this is the error. So what is the percentage error? ACVC is the error. What is the wanted term upon ADVD? Into 100%. That is the error. CMRR, common mode rejection ratio, is nothing but AD by AC. Nothing but AD by AC. So what is the AC by AD? AC by AD will become 1 by CMRR. So always remember the formula. Percentage error is given by 1 by CMRR into VC by VD into 100%. Now everyone please mention what is the ideal value of the CMRR and what is the ideal value of AC. Yes, please. What is the ideal value of the CMRR and what is the ideal value of the AC? Now, VC means V1 plus V2 by 2. So what is the V1 and V2 given in the question? 9,050 and 950. So when we want to calculate the VC, 1050 plus 950 divided by 2. That is 1000 microvolt. What is the VD? V1 minus V2. V1 minus V2. When I am subtracting this 2, it will become 100. Directly use this. What is the percentage error? CMRR, it is given in the question 1000. VC is 1000. It is 100. Microvolt cancel. Always check the unit. This is cancel out. It is a unitless quantity into 100. 1000 cancel, 100 cancel. What is the answer? 1%. What is the answer? 1%. So Ravi Shankar Kirti, what is the ideal value of the CMRR? And other students, please tell me. Now, the ideal value of the CMRR is what? Infinite. And that is the answer. We are having the 1% error. So that is the question on what? Differential amplifier. Basic of the differential amplifier. If you find any difficulty, then please ask me. Now, and that is another information for you. Scholarship test for your GATE preparation. Right? Register now. Link in the description box. If you want to give the scholarship test, if you want to take the admission in BYJU'S Exam Prep, then it is a golden opportunity for you. Register now, and that given in our description box. Okay? Subscribe our channel and press the bell icon. Now next one, what is the next question on your screen? That is one mark question. It is a very easy question. Everyone give me the answer. Sometimes surprisingly we are getting this type of question in GATE exam, but we are not expecting easy question, and that's why we are making silly mistakes. Okay, so around 40% question, around 40 to 50% questions means when we are solving the previous year question, last 20 year previous year question, you can expect around 50% question will be on the same concept. Next remaining 50% question, they will provide you what? A conceptual question, newly designed question, to ready for all those surprises. And they are mixing 1 marks question, 2 marks question, numerical answer time, MCQ, MSQ. So that is, and this type of questions. What is the characteristics of ideal operational amplifier, everyone? For any ideal operational amplifier, basically it is a voltage amplifier. What is the amplifier? Basically it is a voltage amplifier, and that is the internal diagram or equivalent diagram of any voltage amplifier. This is the RI. Voltage across this is VI. It will amplify this VI, and that is called R0. So this is the equivalent circuit of any voltage amplifier, and this is the gain AVVI. Here we are connecting external RS. Here we are giving the VS, and here we are connecting the RL. or across the RL we are taking the output. Okay. So this is a simple diagram. The white portion is what? Correct. Equivalent circuit of voltage amplifier or operational amplifier. Operational amplifier is basically a voltage amplifier. For this, we want to transfer the complete voltage across the RI, and the drop across the RS should be equal to 0. Why? Because it will amplify the voltage across RI only, and that's why we are saying that ideal value of RI should be what? Infinite. Or practical value RI should be very greater than what? RS. RI should be very greater than what? RS. Second, we want the complete voltage should come across what? RL, AVVI. So ideally we want the drop across the R0 should be 0. So ideally it is 0, and practically it should be very less than what? RL. Okay, these two things. Now what about the voltage gain? Voltage gain means internal voltage gain, AV. Ideally we want AV should be what? Infinite, and practically we want it should be as high as possible. So which answer is correct? Option A. RI infinite, A infinite, R0 0. R0 0. So remember that it is basically a voltage amplifier, and what are the ideal characteristics of the voltage amplifier that is applicable for operational amplifier? A practical condition. Always remember the practical condition also. Right? One thing, what is the gain bandwidth product? Ideally it should be infinite, or practically it should be as high as possible. Normally we are having the 10 to the power 6 hertz. Or what? CMRR. CMRR it should be infinite. What should be the AC? AC should be equal to 0. These are the property of the operational amplifier. Why we are talking about the CMRR? CMRR because operational amplifier is basically a differential amplifier. It is a direct coupled amplifier. Direct coupled. First operational amplifier, second operational amplifier, third operational amplifier, and that is called what? Instrumentation amplifier. Is there any buffering? 1 minute. Okay, everything is fine now. I think now everything is fine. Okay. What is the output voltage V0 of the below circuit? Watch this diagram. This diagram is actually a differential amplifier. RF, R1. Always we have to check this. What about this ratio? If this for particular thing, if the ratio is satisfied, this particular device, if the ratio is satisfied, means it is an ideal differential amplifier. So 4.7 divided by 4.7, 4.7 divided by 4.7, it is satisfied. That means it is ideal differential amplifier. Now we are connecting here extra arrangement. We are connecting extra arrangement so that what is the input resistance seen by this battery. So here we are giving, let this is the V1. Right? One thing, always remember there is a negative feedback. So this is the negative feedback here. This is always remember it is a use of the operational amplifier as a differential amplifier. We have to provide the negative feedback. So that feedback is negative. It is a non-inverting op-amp. It is also a non-inverting op-amp because we are connecting the input to the non-inverting terminal. Let this is the V1 and let this is the V2. And because of that V1, at this point we are getting the voltage V01, and at this point we are getting the voltage V02. And it is a ideal differential amplifier. For ideal differential amplifier, if you have the value of V01 and V02, then what will be the answer? Yes, everyone, give me the answer in the comments box. It is a standard circuit. Now, if you know the value of the V01 and V02 here, this is the 1 volt V1, this is the V2. Now, condition is satisfied, and that's why the output is equal to Rf by R1. This Rf by R1 into difference of the non-inverting terminal and inverting terminal. V01 minus V02. Actually, this is the answer for this portion on. You are giving the B. Okay, Ravi Shankar. We will check. Rf by R1 into V01 minus V02. Now, how to find the V01 and V02? V01 minus V02. That is the standard answer for this diagram. Okay. Now, how we can find? When we are applying the virtual short concept, if it has 1 volt, the voltage at this point is 1 volt. If it is a 2 volt, so this is the VP, this is the VN. If it is 2 volt, it is 2 volt. At this point, it is the 2 volt. And what is the current enter into the operational amplifier? 0. Why? Because the input resistance is infinite. If suppose I am assuming that there is a current in this direction or in above direction or below direction, the current will remain same. So current, suppose I am assuming, you can assume in any direction. Let the current in above direction. Let this current is what I. So what is the drop across this resistor? 10 kilo ohm, 2 kilo ohm, 10 kilo ohm. 10 plus 10 plus 2, that is the 22 kilo ohm. Total resistance is 22 kilo ohm. Then we can directly write V01 minus V02 is equal to I into 22 kilo ohm. That is the drop. Watch that. 10 to 10, 22, I. Same current will flow from this point to this point. Why? Because the current in the operational amplifier is 0. Now, what is the value of I? This is the 1 volt, this is the 2 volt. Because we are taking the direction from 1 to 2. So we can write the I is equal to 1 minus 2 divided by 2. I is equal to 1 minus 2 divided by the 2 kilo ohm, that is the minus 1 by 2. Minus value, because I am taking from in upward direction. It will become minus from lower potential to higher potential. Then what is the value here? V01 minus V02 will become minus 1 by 2 into 22. That is minus 11 volt. Once you have the minus 11 volt, put here minus 11. What is the RF at R1? 4.7, 4.7. It will become 1. 1 into minus 11. What is the answer? Minus 11 volt. Answer is minus 11 volt. A is the answer. A is the answer for this question. Yes, very simple. To find this differential amplifier, and then you can choose any direction of I, below or upward. You have to find the V01 minus V02. And you have to check this ratio. Check this ratio. That is all about the instrumentation amplifier. This is of 2 marks question. And it is a MCQ. Okay. So everyone, if you are giving the wrong answer, then there will be the negative marking in case of what? MCQ. So be careful about the MCQ. If it is of 2 marks and if you are going to give the wrong answer, there will be the minus 2 by 3 marks. If it is of 1 marks, then minus 1 by 3. Okay, then next question. Oh, that is the question on what? Integrator and what? Differentiator. Now, another application of the operational amplifier, linear application of the operational amplifier, integrator or what? Differentiator. Okay, what is the answer? What is the answer for this one? I am trying to cover what? All type of portion. First of all, non-inverting op-amp, practical, inverting op-amp, voltage follower over differential amplifier, voltage to current converter, current to voltage converter. Okay, already we have covered. And instrumentation amplifier. Now some questions on filter. Some questions on filter. Yes, Ravi Shankar, all try to solve all the homework and give me the answer on the comments box, and I will provide you the answer for those questions on my Telegram channel. Okay. Finally, tomorrow I will provide you the answer for all the 20 questions. I have to take 5 sessions. Tomorrow it is my last session on waveform generator, sharp at 4 p.m. and I will provide you the answer for all the questions on my Telegram channel, that is Electronics by Sanjay Rathi. Tomorrow we will discuss the Schmitt trigger circuit. Assume that the op-amp of the figure is ideal. What is the Vi is the triangular wave, then what is the V0? Remember that if the C is connected here, it is a 1 mark question. Why 1 marks? It is a standard circuit. It is a standard circuit. If the C is connected here, R is connected here, then it is what? Differentiator. Differentiator. Or if suppose we are changing the position, here we are connecting the C, here we are connecting the R, then it will become integrator. So it is a differentiator. If the differentiator, if we are providing a triangular wave here, so what is the differentiation of the triangular wave? The differentiation of the triangular wave is square wave. Very simple, right? To go through the theory, already number of sessions available on my operational amplifier, right? That is by me, and you can get the idea why it is called the differentiator, other circuit is called the integrator. Then standard circuit, differentiator, we are giving the triangular wave, output will be the square wave. Within 20 seconds we can give the answer. 1 mark question. Next one, everyone tell me, what is the name of this circuit? What is the name of this circuit? It is a filter circuit. It is a filter circuit. What is the name of this circuit? You are not giving answer in the comments box. Try to give me the answer in the comments box. The operational amplifier circuit shown in the figure is a filter. The type of the filter and its cutoff frequency are respectively. Okay. Now, right. High pass filter, low pass filter, high pass filter or low pass filter. There are two options. Second option, what is the cutoff frequency? Okay, so you are giving the answer A. Other students, please give me the answer. Whether it is a high pass filter or low pass filter. Now, always remember, if this is the circuit, here we are giving the output, here we are giving the input, here output. So this is a high pass filter. And this is the low pass filter. These two are called passive filter, low pass filter, high pass filter. No active element is involved. When we are connecting a non-inverting operational amplifier. What is the non-inverting operational amplifier? This is the non-inverting operational amplifier. Right. This is the non-inverting operational amplifier. What is the gain of the non-inverting operational amplifier? 1 plus RF by R1. 1 plus RF by R1, that is the gain of the non-inverting op-amp. And what is the phase shift? 0. Shivam, yes, high pass, okay. Phase shift is 0. Now, what is the gain of this? And what is the cutoff frequency of this system? It is a high pass filter. We can directly say it is a 1 by SC. So, what is the gain? R upon R plus 1 by SC. So gain will become SCR upon 1 plus SCR. Or you can put the, in place of S, you can put what? J omega. You can put the J omega. Okay, no issue. Now when these two are connected in cascade, just like a previous diagram, so non-inverting, and here we are connecting RC, and this is the VI. So it is nothing but a high pass filter followed by what? Non-inverting operational amplifier. So what is the purpose of the non-inverting operational amplifier? The purpose of the non-inverting operational amplifier is to increase the gain of the system more than 1, and it will avoid the loading effect. Now, what is the cutoff frequency for this? 1 by RC. It will remain same, 1 by RC in radian per second. So, cutoff frequency for this is 1 by RC. This R and C. This is the C, this is the R. So, 1 by 10 to the power 3 into 10 to the power minus 6, it will become 10 to the power 3 radian per second. 1000 radian per second. So it is a high pass filter and 1000 radian per second. If suppose we are changing the position of the R and C, it will become low pass filter. Remember that. It is an active filter, right? Simply, what is the maximum gain? If it is asked what is the maximum gain, you can directly write 1 plus RF by R1. The maximum gain of the system is 1 plus RF by R1. Okay, then that is the cascading of non-inverting and what? Passive filters. This is a very simple diagram. Now, okay, everyone, give me the name of this circuit and what is the answer? What is the answer for this question? Shivam, out cutoff frequency is equal to 1 by RC. Yes, yes, yes. That is right answer, 1 by RC. Consider the operational amplifier circuit shown in the figure. What is the name of this filter? Everyone. If Vi is equal to V1 sin omega t and V0 is equal to Vt sin of omega t plus phi. V0. Here V0 is the V2 sin of omega t plus phi we are getting. And here actually we are giving V1 sin of omega t. There is a change of what phase? Phi. It is changed by what? Phi phase. Now what is asked here? Then the minimum and maximum value of phi. And that is given with sign. So always remember what is the sign. Whether it is negative. If it is negative, that it become minimum and maximum. What is the answer for this question? What is the name of this figure? This is called what? All pass filter. All pass filter. And for this all pass filter, we have two standard circuit. For all this all pass filter, we have the two standard circuit. So this is the first standard circuit where R and C, and what is the second standard circuit? Remember that. Same diagram, simply change the position of R and C. Right, there are two diagrams. These all are what? All pass filter. Yes, we will check. You are giving the B answer 0 and pi by 2. Okay. Now, for this diagram, it is, watch that. You can remember this is a low pass filter like this structure. Overall circuit is all pass filter. And low pass filter is lagging circuit. Lagging. And answer for this question is what? It will provide the phase shift. The minimum phase shift provided is minus pi. Always negative. And maximum phase shift provided by this is 0. So this is the minimum phase shift. This is the maximum phase shift. And what is the minimum phase shift here? 0. And what is the maximum phase shift? Pi. So remember that this is the high pass filter, and always the high pass filter is what? Leading circuit. So it will provide a positive phase shift, it will provide a negative phase shift. So these are the two circuit, standard circuit, right? And from the standard circuit, always remember the standard answer. It is nothing but 1 marks question only. And it is MCQ. Within 30 seconds, we have to give the answer. And what is the answer for this question? Minus pi and what? 0. Minus pi is the minimum value and 0 is the maximum value for this. Okay, now time for assignments. Are you ready? Are you ready to solve some questions? We have some important questions for you. Right. First of all, give me the answer for this and then assignment. For the operational amplifier shown in the figure, the bias currents IB1 and IB2. Bias current IB1 and IB2 is given. The values of the input bias current and input offset current. Normally, input offset current and input offset voltages, these are this type of questions in what? Instrumentation branch. But that is in the syllabus of electronics branch also. They can ask. But it is important for instrumentation branch. If it is important for instrumentation branch, for the op-amp shown in the figure, the bias currents are IB1 and IB2, 450 and 350. The values of the input bias current and input offset currents are, what are the values? Yes, please. One minute. And that is another information for you. The free gate workshop. Register now. Link is given in the description box. So that is very, very important. For all the free workshop, you will get the detail in our description box. Right? For ebook, you can go through the description box. Then for workshop, you can go through the description box. Okay. Now, try to solve this question. What is the answer? For the op-amp shown in the figure, bias current. Remember, if we are having the two separate currents, IB1 and IB2, to bias current, what is the formula for the bias current? Average value of this. This is a very standard formula, average value of this. And what is the offset current? Input offset current is the difference of this. Difference of this. So what is the average of this? 450 plus 350, that is the 800 divided by 2. So 800 divided by 2 is what? 400. This is the standard answer for input bias current to 400. And what is the difference? 450 minus 350. What is the difference? 100. So 100 is what? IB. D. This is the question on what? Input offset current and input offset, input bias current and input offset current. Okay, so that is the standard formula, IB1 plus IB2 by 2 and IB1 minus IB2. Okay, guys, that is my suggestion, especially for instrumentation branch and electrical branch. Right, it will take around half an hour, 30 minutes to get the command over what? Input offset voltage, input offset current, input bias current, and get the idea about this topic because it is important for your exam. Okay, so every marks is important. And then now it is time for assignments. This was the last question. So everyone, please try to solve this question. First question on your screen. What is the V out? That is the first assignment. And that is again on what? Input bias current. What is the effect of the input bias current? So that is the problem with the input bias current. Go through this, go through the theory of this and try to solve this question. For answer, join my Telegram channel, Electronics by Sanjay Rathi. Second, now tomorrow I will discuss this question to everyone. This is a question on oscillator, operational amplifier by oscillator by using operational amplifier. So what is the name of this circuit? That is given here. Try to solve this question. This is the assignment number 2. Tomorrow at 4 p.m. we will discuss symmetry trigger, bistable multivibrator, monostable multivibrator, relaxation oscillator, right? All type of questions. Then I will also discuss this question. This is a very, very important one. Second assignment. Then solve this one. Consider the circuit as shown in the figure. Let ZL is equal to 100 ohm, and that is the value. All the values are given, R1, R2, R3 and V1. So what is the load current in this diagram? So redraw the diagram and you will get the idea what is the load current you have to find. This is a very, very important question. Assignment number 3. Okay, take the screenshot of that. I will upload the PDF. Then finally, the 4th assignment, that is on your screen. A circuit consisting of the capacitor, DC voltage source and an amplifier having a voltage gain G minus 5. That voltage gain is given G minus 5. The effective capacitance across the node A and B. You have to find the what is the effective capacitance across node A and B. Okay. And my dear friends, I am giving you the hint. When you want to find the effective capacitance at this point means what? Thevenin's. We have to apply what? Miller's theorem. We can break this 2 microfarad by using the Miller's theorem. Then apply the series and parallel connection of the capacitor, and then you can find the what is the effective capacitance at this node. Okay, at this node, what is the effective capacitance? And you can use the concept of what? Thevenin's theorem also. Thevenin's theorem. But you have to use the Miller's theorem. Miller's theorem. Break this capacitor and then apply the concept of what? Thevenin's theorem, and you will get the answer for this particular question. Okay, Payas Kumari, very good evening. Okay, no issue. Please watch the recorded lectures and try to solve all these 4 questions. These are the assignments, right? And for answer, join my Telegram channel. For PDF, join my Telegram channel, that is Electronics by Sanjay Rathi. Okay then hope so you enjoy the session. Tomorrow we will discuss what? Waveform generator. Then you are on Byju's exam prep. Like the session, subscribe our channel and share the link of this session. Thank you very much and good day.